All right, so the first piece of evaluation we're going to do on the 6-stage rubric is authenticity, and we're going to start off with Coach C.
So there's a lot of different ways that this project is authentic. I mean, the students are building real catapults, and they are attacking a real castle. But in the world outside of our school, they do a pumpkin chunking competition where they actually try to make the best type of catapult, and there's different categories and different styles of how they build them, and they shoot a pumpkin close to a mile. So it's really, really impressive. They also use this at Renaissance festivals. There's a huge one up here in Ohio that the students actually, some of them go to, and I go to every year, where they actually make little miniature ones, and they explore how those work and how to use them.
In addition to this project, the students actually created their own driving questions for it. So as a class, we had each group to develop a driving question. We then voted on which one we think was most appropriate for the project. So the driving question was something to the effect of, how can we as catapult engineers build a catapult to perform a siege on a real-life castle? So we gave them kind of background information on medieval times and a castle that actually had a siege done on it, so they could have a little bit of application to the problem, and then, of course, connect it to the Renaissance Festival. In addition, at the end, they had to kind of defend their solutions and defend their work because they got X number of shots on an actual castle that we built in the middle of the room, and they had to show us the calculations for how far away their catapult needed to be in order to hit the army men or whatever target they wanted to on the castle. In order to make each of those shots, those calculations had to be submitted to us prior, so they could kind of defend how they learned the information, how they applied it, and how their catapults would then actually be able to attack the people on the castle.
So they actually did this individually. Every student had their own calculations based on their group's initial velocity of their catapult that they actually built. And then they had different targets they had to attack from different heights. So they actually had to do different calculations on the range and the kinematics and that kind of stuff for physics. And the students were able to show how to each hit a different target.
And for mathematics, the importance of modeling was kind of at the forefront of this project. So the idea that different types of models will give you different types of things that are important with respect to a problem or project. So what they had to do is have 3 different models, one that's quadratic models, one that's in conic form, one that's in standard form, and one that's in vertex form. Standard and vertex were both reviewed from their Algebra 2 year, and then that kind of expanded to conic form, and they had to understand not only how to find each of the models, but how each of them was beneficial in their own specific way.